Hi, welcome to Mary's Math Club.
Rotational symmetry is also known as radical symmetry in biology. Very simply, rotational symmetry means we are getting the symmetry after rotation of the object. So when an object means the orientation of an object after partial turn is going to be similar or looks like same with the original orientation of that object or shape, then we are getting rotational symmetry. Here the word of partial turn, here the word partial turn is very important. What do you mean by partial turn? Yes, we have to make our idea clear about this. See, this is suppose R, a letter R. It's a shape. And now this side is curving and this side is straight line. So if I say that this letter R I am turning, means it is now right now here. So it is the original position, suppose. So I am now turning. R is rotating, partially rotating, partially rotating, again coming to the same point from where it was started. Again coming to the same point from where the R started to rotate. Started means started to rotate. So this is the way R started to rotate and again came back at that point. And then this orientation means this shape, means the shape of R is going same, means this side is curved line, this side is straight line, and there is a lobe. All these things are on the top. So all these things are same. So the orientation again similar from the original orientation. That full turn is called, this is called full turn. And we know that this full turn means from one point again rotating and reaching at the same point from where we start. Means start and stop in the same position. Then it will gives us an angles also. Angle is nothing but the value of the angle is nothing but 360 degree. So this is our complete turn. This is our full turn. And so from there, here, we easily understand that partial turn means it can be here, it can be up to this, it can be up to this, it can be up to this, but not up to this point. Because if it will come to the same point from where it was started to rotate, then it will be complete rotation, full rotation. So, partial rotation means it will rotate before the point of the starting point. So that is called partial rotation. Now another thing is that when one shape or one object is rotating, in the case of 2D figure, it will rotate with respect to an internal point. And in the case of 3D figure, it's rotate with respect to an internal axis. So in the case of 2D point, it is rotating with respect to one internal point, an internal point. And in the case of 3D figure, it is rotating with respect to an internal axis. Now suppose this is number 7. This is number 7. Suppose I am just drawing this number 7. So it is our number 7. And generally the center point with respect to this point, I am rotating. I am rotating the 7. Okay. Now clearly, when I rotate its center in this with respect to this point, means like this. Here was the 7, and now with respect to this point, I am rotating. So see, it is not partial turn, but it is again same when it is going one full rotation. If this is true for every object, then whenever it will take a full turn, then it will automatically, its orientation will be same. And that's why when we will find out the order of the rotational symmetry, then we don't consider the full turn. We will, with respect to full turn, we will consider, but we will not take the full turn. Means one object is full turning, so its order is 1, we can't say, because it is true for everyone. Whenever it will take full rotation, that means its orientation will be same. Now, the point with respect to what I was rotating, this point is called rotational center. Rotational center. And one thing you already have seen, and again I am also explaining that. Now one thing I will say again, that when we are rotating, this at the time of full rotation, we have already seen that if we start from here, and after the full rotation, it is also giving an angle, producing an angle that is nothing but 360 degree. So what's about the partial turn? See, suppose it is our starting point. Okay, I am starting from this point. This is oval shape, so it looks like this. Now I am rotating with respect to this point. What is the center point? Okay, now I am rotating. It is not similar to the orientation what was original, because original orientation was here, and now I am rotating, partially rotating. But now see, this orientation is same as the original orientation. So now I am giving here a dot, and now join this straight line. Okay, I am indicating with red color. So this is one straight line we are getting. We started from here. So here to here, it is also producing an angle. It is producing an angle, and this angle we are getting by partial turn. Just like that, if it was going similar here, the original with the original orientation, then we will get this type angle, this total angle. So getting this angle. Again, if we go further, means if our original rotation means if our orientation of the object is going to same with original here, then we will get this big angle. So we are getting angle. So we are always getting an angle when there is a partial turn also. And this angle means which angle we are getting for partial turn of the object. This angle is known as rotational angle. This angle is known as rotational angle. Rotational angle. So this is our rotational angle. This is our rotational center, and now we will discuss about the order of the rotational symmetry. Now we will discuss about the order of the rotational symmetry. What is the order of the rotational symmetry? What do you mean by it? Means, suppose here I am taking one figure, suppose letter H. Suppose the letter H. This is the letter. Drawing this a little bit different way. This is the H. This is our letter H. Now, see this letter H clearly from the picture that it will, if we rotate it, it's through this point. Here rotational center is here. I am indicating it by black one. This is the point. This is the point of rotational center, okay? And with respect to this, I am rotating H. So when the from starting from here of H, and now when I am starting from there to rotate it, I'm rotating H. So now H will be looks like this. Now H will be looks like this. Now H is going looks like this. And now when I am coming again here, then H is looks like this. Means the orientation of H, and this H is same. So here we are getting symmetry. So I am getting rotational symmetry of H here when H is in this position. And order of the rotational symmetry is what I am saying, that we got two angles. I am writing order of rotational symmetry. Previously we have seen we got two angles. One angle we are getting when it is full turn, means complete turn, and one angle we are getting the partial turn. Partial turn means where it is in between full turn, but or you can say before full turn, where we are getting the rotational symmetry. So in the case of this, if we I am making a line. So this angle is nothing but 180 degree. And this is our angle produced by partial turn. So order of rotational symmetry will be full angle we are getting from the full turn. Full turn means it will be 360 degree by the angle we are getting, angle produced by partial turn. So the order of the rotational symmetry is equal to angle produced by full turn and the angle produced by the partial turn. And see here, we will find out in this case what will be the order of the partial or rotational symmetry. See here full turn we have already seen. For full turn we are getting 360 degree angle, and here for partial turn I am getting 180 degree. So here the order of the rotational symmetry is 2. So here the order of the rotational symmetry is 2. Now I will again show this thing, find out this order of rotational symmetry in the case of square. So order of the rotational symmetry is complete angle by rotational symmetry angle. Sometimes rotational symmetry angle is simply say rotational angle also. Now we are examining this order of rotational symmetry with respect to square, triangle and circle. See, in the case of square, if it is start from here, then when I am starting to rotate, when it will come to this position, we are getting one orientation which is same with this original orientation. Again, when it is coming, so this is one time we are getting the original orientation. Again, when it is coming to this position, we are getting the another orientation which is similar, which is same with the original orientation of this shape square. So the order of the rotational symmetry of square here will be, I am writing, it is just writing order as my space is little bit. So order will be according to our rule, it will be full angle produced by full turn means 360 degree always. Same for everyone, because for any shape, I already told it and again telling that for any shape, whenever we will do the full rotation, means whenever I will rotate it for 360 degree angle, then automatically it will get the original orientation. It's an identical thing. So that's why we are not considering the full turn rotation. We are always taking the partial turn. So here for partial turn, first here when it is coming from here to here, means it is making, see, 90-degree angle. So the angle produced by partial turn, where it is going to, the orientation is going to be same with the original orientation of the shape. So it is 90 degree. So now 360 degree by 90 degree. So it is 4. So order of the rotational symmetry in the case of square is 4. And now for the triangle. It's a scalar triangle. Now for the triangle. See, it is a triangle and this white dot is the center of the rotation. Now I am rotating. Here is the starting point. Starting point. I am rotating the triangle. I am taking, means this triangle will be rotated like this, this. So when it will come to this, means this angle is going to here. It's not with the original orientation. Again, it is not original orientation. And again, it is not original orientation when the triangle is not an equilateral triangle. Because only when it is taking full turn, only then it is going to same with the original orientation. That means it has no rotational symmetry. That means it has no rotational symmetry. Now in the case of circle, if I move the circle a little bit, means the partial turn I am saying about, see, if it is my starting point. And if I a little bit, okay, the same is just circular. I think it will be easier if we think with this. See, we are starting with this. Now I am rotating, same with the original one. Then again rotating, it's same with the original orientation. Again rotating, it's same with the original orientation. So in each of the point, we are getting original orientation of the circle. And that's why in the case of circle, the order of the rotational symmetry is infinity. In fact, in the case of circle, the reflectional symmetry or linear symmetry was also, means axis of symmetry was also infinity. So this is in the case of circle, but not that always if the object or the figure has the rotational symmetry, means that will be has a linear symmetry, or vice versa, the linear symmetry, so it will be rotational symmetry. Not like that. It may or may not be. It's depending upon. So we are getting that for different shape, for different figure, the order of rotational symmetry is going different. And when sometimes it is order of the rotational symmetry is 2, sometimes 3, sometimes infinity, like this. And that's why according to their number of the rotational symmetry, there's some name also we call, that is, suppose the order of any rotational symmetry of any figure or shape is n. Then we can say rotational symmetry of order n, or n-fold rotational symmetry, or discrete rotational symmetry of nth order. And according to the order numeric, we sometimes say that if n is equal to 2, then we call dyad. If n is equal to 3, then called triad. If n is equal to 4, then called tetrad. If n is equal to 6, called hexad. If n is equal to 8, called octad, and so on, like this. Some cases we will not get the rotational symmetry. Just like in the case of number 5. Say it is the number 5, here is the straight line, here is the curved line, here is the straight line, and this position like this. So when I am rotating, so I am not getting any position before 360 degree, that which is where orientation is the same with the original one. So I am not getting any rotational symmetry here. Just like in the case of 4 also, or in the case of 3. See, it is not giving. But in the case of 8, there is rotational symmetry. So you must check it with the letters and numbers when you are getting the rotational symmetry or not. Like, share and subscribe my channel. Bye.